Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay and in high spirits. Date today is August 19th, 2024, and my topic of discussion under Physics Lesson 23 is we're going to solve a numerical problem in physics which involves uniform acceleration or uniform motion. So, in my last topic, I introduced you guys with uniform motion, and today we're going to solve a numerical example. Now, before I get started, I've been teaching uh, calculus, algebra, circuit analysis, network engineering, physics for almost a year. And I've been really excited about it, to transfer knowledge from myself to others. Initially, when I started, I had 90%, I would say 90% of my students were male students. And I kept on wondering what happened. How come I don't have more female students? Are they not interested in science? Boy, was I wrong. I was wrong. And I'm proud to say that I was wrong because now my female student population is 50%. Initially, it was barely 10%. Now it has reached 50%. So I'm going to say woohoo for all of my female students. So can I get a woohoo from you guys? Please send a message saying woohoo for all of the female students. I'm so proud of them. This is fantastic. Having said that, let's go ahead and look at this problem right here. We have uh, first of all, this is the formula which you have to remember all the time. And I introduced you this formula in my last section. This x right here is the distance we are finding, total distance from point A to B, final distance. This x0 is initial distance. Okay. This v naught or v0 is initial velocity. Okay. Initial velocity, that means that when we started looking at the problem, you know velocity at that time. Don't misunderstand that you're looking, if it says v0, you're looking at time zero. No, car could be running at 10 miles per second, and that's when you started looking at it. So then v naught or v0 will be 10 miles or 10 meters per second. If the car is sitting and not moving, and you're looking at that, you've been asked to look at that, yes, then velocity, initial velocity, it could be zero. Okay, so there is a difference. A lot of students mess up, when thinking about, v naught or v0, initial velocity. So always read the problem a couple of times before you dive into it. Anyway, this is a picture right here, a baseball pitcher or a cricket batsman or some sort of person who's hitting the ball, all right, and hitting this target right here. So this person is hitting this ball. Let me draw a ball right here. Okay, is hitting this ball at 120 meters per second and to this target. Okay, now the distance is given from the pitcher to the target is 60 meters. All right, what we have been asked is to find out how much time does it take for the ball to reach from the pitcher all the way to the target. So what do we have to find out? Time. Okay, time it takes. Now my question to you is, you'll have to look at this formula right here, which I introduced you in my last section, and basically find out t from here. Okay, now what is my x in this case? X is basically distance covered from point A to point B. It's given 60 meters. Okay, and then what is my initial velocity? Okay, when you started looking at the problem, 60 120 miles per second, it's given right here. 120 meters per second, my bad. Okay, so now you have been given x you have V naught, okay, and this X, this 60 meters. So what do we have to find out? We have to find out T in this case. Now, let me ask you this. What is X of 0, X naught in this case? X naught is when we had just started distance wise, okay, that is 0 right here, okay. So now all we got to do is plug in, do some algebra, and we can solve the problem. So we can say X, which is 60, okay, is equal to X0, all right, initial distance when we started, that's right here, which is 0, okay. So we have 0 plus, what is the initial velocity when I push the ball? Boom, 120 meters per second. So 120 times t, okay. If you solve this, do some algebra, so t is equal to 60 over 120, okay. So which is basically half a second, or you can say 0.5 seconds. Okay, well, that's pretty good. Fast picture, I guess. So luckily in this particular problem, the unit of measurements, meter per second, meters, time in seconds, all the units were same. I'm going to come up with a problem. Follow me on the next section. I'm going to come up with a problem where the units are going to be different. How do you tackle that? I'll explain you in my next topic. Stick with me. Follow me to the next lesson, and we'll solve another numerical problem. Thank you for watching. Have a good one.